This video is just to review some of the big concepts we've learned in Mod 8b. So I'm just going to go through some examples similar to other things we've learned in this unit. Okay, so one thing to remember is that exponential we can rewrite as a radical when it's a fraction exponent. This is the same as square root of 4 to the third, or I can think of square root of 4 to the third. Those are all the same. I usually prefer to do the root first, so I'm dealing with smaller numbers. So square root of 4 is 2. 2 cubed is 8. Okay, or if I did 4 cubed, that's 64. Square root of 64 is 8. Get the same thing either way. Okay, so this one is the fifth root of 32 cubed. Fifth root of 32 is 2, which is also then 8, 2 cubed. Okay, remember we can take the odd roots of a negative. So fifth root of negative 32 and then to the third. So I'm going to get negative 2 there. And negative 2 times itself 3 times is negative 8. Okay, when I can, I want to pull out perfect factors. So I want to see, can I rewrite things to the third power? Anything to the third power, I could then take the cube root of and pull out front. So this is the same as the cube root of 8 times 2. And why that is useful, you guys, is because 8 I could rewrite as 2 to the third. So these pieces, the cube root and cube, are going to cancel. So the 2 and the x are going to come out front. And then we have cube root of a 2 remaining and x squared remaining. Okay. Now we have something called reducing index. There's nothing I can take the 8th root of out of 16. But 16 I could rewrite as 2 to the 4th. So this is the same as 8th root of 2 to the 4th, which is the same as 2 to the 4 eighths. And 4 eighths I can reduce to 1/2. So you can leave it like this or rewrite it as square root of 2. Either one of those. This is called exponential form. This is called radical form. Okay, cube root of 4 to the 9th. Okay, so this is the same as cube root of 2 squared over cube root of 3 squared. Okay, so I do not want a radical in the denominator, so I need to make it so I have something to the third power. So I have 3 to the second power, so if I were able to multiply by another 3, that would give me 2, if I combine these here, I'm going to get cube root of 3 cubed. And because of that, the cube root and the cube will cancel. Here, I'm not able to really combine much more, so this is just going to be 4 times 3 under there. Okay? So, oh, sorry, this should be cube root. Okay, so I have cube root of 12 over 3, right? Because the cube root and the cube will cancel. As long as I don't have a root in the bottom of a fraction, it is rationalized. When we add or subtract radical expressions, the radicand must match. So I'm going to break this one down. This I can break into 4 and 2. Square root of 4 is 2. And that's just going to be 0. Going to cancel. Okay, here when I distribute, so I'm going to do here, root 3 and root 3 are just going to be 3. 2 times 3 is 6. Here I'm going to get minus 3 root 3. Here I'm going to get 4 root 3. And then 2 times negative 3 is negative 6. Okay, so 6 and negative 6 are 0. Here, this is going to be 1 root 3 or just root 3. Okay, to rationalize this one, if we have addition or subtraction, we multiply by the conjugate, which is 1 plus square root of 7. So it's the same exact thing, but opposite sign. So we have 2 times 1 plus root 7. Difference of squares is 1 squared minus square root of 7 squared. Okay? So let's see here. We've got, I'm just going to leave it like this for right now. Okay, here I have 1 squared minus 7. So we get 2, 1 plus square root of 7 over negative 6. I could reduce that to negative 1/3. So I get 1 plus square root of 7 over negative 3. All right, a couple more. All right, solving. We want to isolate the radical first. Okay, so I'm going to add 2 to both sides. So I've got cube root of x equals 2. Then to undo the root, we are going to cube it. So x is equal to 8. Okay, here I have a radical in the form of a fraction exponent. Remember, we're going to multiply by the reciprocal to make this equal 1. This then is the cube root of 27 squared. Oh, I'm sorry. Yeah, we're good. Okay. And cube root of 27 is 3. 3 squared is 9. Okay. Now here I need to square both sides. We're getting rid of the radical. So this is 2x plus 3. What happens here, remember this is the a and the b that we talked about here. So this is going to be 9 minus 2 times 3 times 2x, so minus 6. And then this squared is going to be 2x. Okay? Going to move everything over here. And I think this is exactly the same as another problem we did. So negative 6 equals negative 6 2x. Divide by negative 6. So we get 1 equals square root of 2x. Square both sides. Get rid of the radical. So I'm left with 1 equals 2x. So x is equal to 1/2. Okay. This one I believe does check out, you guys, but remember to check solutions. Just gonna write that as a note. Okay. Here, if I square both sides, okay, I get x squared equals negative 1 minus 2x. Set it equal to 0. Factor. Okay, x equals negative 1. Now, I especially want to check here because it's negative. So I'm asking, does negative 1 equal square root of negative 1 minus 2 times negative 1? Okay, so let's see, we get negative 1 plus 2 is 1, and this is not equal. So because of that, there is no solutions. All right, last piece here, you guys, is just a review of some graphing. So it's really important that you know what the parent functions of this unit look like. So square root function, big 3 points are 1, 1, 0, 0, and 4, 2. This guy is going to reflect over the x-axis and then move up 1. So we're going to reflect over the x-axis and then up 1. Reflect over the x-axis, up 1. Reflect over the x-axis, up 1. Okay, once I do that, oh, sorry, a little curvy there. Okay, so now it says to identify the domain and range. So the domain is 0 to infinity. range, negative infinity up to 1. Okay. Now, this guy, cube root function, parent pieces, those 3, and then 8, 2, and -8, -2 are 5. Really, those 3 are kind of the big ones. So this one's going to move right 2 and down 3. So we're going to go right 2, down 3. Right 2, down 3. Right 2, down 3. 2, down 3. Right 2, down 3. All right, so this one looks exactly the same. It's just been shifted right and down. Domain and range for the cube root function are always all reals. Okay, one more. Okay, cubic. The big ones here are these 3, and then 2, 8, and -2, -8 would give you 2 more. Okay, so this one is a reflect over the x-axis and multiply by 2, and then up 2. So reflect, multiply by 2, and then up 2. Reflect, multiply by 2, and then up 2. Reflect, multiply by 2, and then up 2. Okay, reflect, multiply by 2 is going to make it way too big, so I'm just going to use these guys. Okay, and domain for the cubic function is all reals, as well as is the range. Okay, that's it, you guys, for the review. Thanks for watching.